Hey guys, thank you for watching. This is the CE 2450 exam one SI session, and I'm your SI leader Hong. Today I'll be going over some key concepts and the stuff and material that you guys have been covered so far up to this point. Um, yeah, so this exam will be covered from book session 2.1, which is from the 2D vector up to like 3D moment about a point. And yeah, so let's just begin with today's stuff. So what does the exam one cover? So well, the exam one covered 3 multiple choice and 1 free response problems. So those 3 multiple choice going to be on 2D resultant force, 2D equilibrium system, and also 2D moment. Okay, and if you guys have been watching my previous SI videos, which is from last semesters, then you guys should already be familiar with this. Should already be familiar with those concepts. So for 2D resultant force, all I really have to do is that this is either going to be a parallelogram law problem or just using the summation of force in the x and y direction. And then for the 2D equilibrium system, you will get problem like springs, pulleys, ropes, in tension. So for those kind of problem, you're also going to use your summation of the force problem, summation of the force formula to solve this problem. But when you encounter a spring problem or a pulley problem, the approach might be a little different. But I'll be covering in today's SI session. And then for the 2D moment, this is very, very simple stuff. We know that all you have to do is just apply this formula right here, and making sure that you guys understand the concept that when you're doing a 2D moment, okay, if the direction is clockwise to a point, you assume that that's negative, or a direction is counterclockwise to a point, you assume that's positive. Well, you can flip them though. Like you can say clockwise positive and counterclockwise is negative too, but you will still get the same answer. But I like to stick on this way. So throughout entire course, okay, I like to stay at this way throughout entire course, so that because this way of approach is more universal. Okay, so it's will be much more easier. But like you can do it the other way around. You will still get the same answer. And then the only equation that you can apply here is moment is equal to, oh, my bad, this should F, not R. This should be F, which is the force multiplied by the perpendicular distance. Okay, I'll cover it in today's SI session. And for the free response problem, it's a 3D moment problem. And this 3D moment problem is going to be a moment about a point, and in which you will have to, in which 3D moment problem, in order to solve this kind of problem, you need to have some fundamental knowledge from 3D vector stuff. And then the only new thing about it is the cross product that you have to do at the end to find out what the moment is. But other than that, I'll say 3D moment and 3D vector problem are pretty much the same, except that 3D moment added a cross product at the end, in which in order for you guys to use to find out what the moment is. Okay, and then next thing is the angle between two vectors, and in order to do that, you need to apply the dot product, which dot product is equal to cosine inverse of force one vector multiplied by force two vector, and then divide by the force one vector in the magnitude and force two vector in the magnitude form. Oh, and then also the cross product, formula is moments equal to R cross F. Okay, be careful with this sign right here. This is not a multiply that sign. This is the cross sign. Okay, and then this will turn into Rx, Ry, Rz multiplied by Fx, Fy, and Fz. And then from this point on, if you want to find out what the I is, I will simply just be all you have to do is cross out the row where the x is at and cross out the column where x is at, and then do ry multiplied by fz minus rz multiplied by fy. So this would be ry minus ry multiplied by fz minus rz multiplied by fy. Okay, and then that's for the I. And then for the j, all you have to do is that j, well, be careful that when you're doing the j, you always want to assume that the j is negative. I mean, my bad, not assume that j is negative, but always put a negative sign in front of the j. Okay, so for I, this is positive. And then for j, don't forget that you always want to put a negative sign in front of it. And then for the j, it will be the same. So let me zoom in right here. So it will be the same. Cross out the row where j is at, which this is I, this is j, this is, okay. So cross out the row where j is at, and then let me erase this. So you cross out the row where j is at, and then also cross out the column where j is at, and then do rx multiplied by fz minus rz multiplied by fx. Okay, and then for the z, which is a k, what I have to do is simply just, okay, cross out the row where g is at, and then also cross out the column where z is at. Okay. And then don't forget that for z, you can have a positive sign in the front. Only I and z, I mean, my bad, only I and k, you can have a positive sign in the front. But for j, always put a negative sign in the front. So k is equal to rx multiplied by fy minus ry multiplied by fx. Okay, and then just find out what, and then just do the sample multiplication and subtraction to get what I is, what j is, and what k is. And also remember that for a moment about a point, your answer is always going to be a Cartesian vector form, which you will have your I component, j component, and k component. It will not be a single magnitude. For a single magnitude, that's moment about a axis, which you guys will be covered. I'm not sure if you covered that in the class yet, but I know that that's not going to be on the exam. So for right now, please remember how to do the cross product. And also for the angle between two vectors, notice that there's two forces right here. So let's say if I have a force F1 right here and F2 right here, and what I want to do is to find out what the angle between them is. So at that moment, you have to apply the dot product when you're doing the 3D moment problem. Okay, and then please remember that this F1 right here and this F2 right here is a vector, which means that they will have to be in the Cartesian vector form. Okay, and then this F1 right here and this F2 right here is the magnitude of the F1 F2 vector, which means that you have to put that in the magnitude form. And you guys know how to do the magnitude form, right? So simply just I squared plus j squared plus k squared, okay? So that you can turn a Cartesian vector into a magnitude form, okay? All right. Okay, and then just some test tips and reminder for you guys. So the test is about an hour long, and I think he assigned different session into different into different testing rooms in Lockheed, right? And so the test is about an hour long, and basically you are doing 4 problems. But if you think about it, the free response problem is going to take probably around like, I'll say 20 to 30 minutes to do. So it will probably leave you not a lot of time to do those like multiple choice problems. So what I would say is that read all the questions at the beginning, make sure you understand what the question is asking, and then focus on higher weighted quick questions. So which means that don't stick at one problem for a long time and then trying to figure out what the answer is. I would say jump to the easier problem first, the one that you know how to do, and then get those easy points first, okay? And then you will have the beginning 3 minutes to ask him any questions about it. And for his exam, I would say it's not difficult, but it's harder than the quiz and the example problems that you guys work in the class. So I highly suggest you guys look over the textbook problems and do a lot of practice on those and just really just really trying to understand the key concepts and what kind of equation to use for different kind of problems. Okay. All right, so let's just begin with the concept first. So for the 2D resultant vectors, we know that first we can use a parallelogram law, which means that if I have two forces right here, let's call this F1 and F2, okay? I can, and then this is the XC. This is positive Y, this is positive X, okay? You can draw this, those two vector, which is parallel to themselves, and they will form a parallelogram. So you can bring this F2 up to right here, okay, and F1 right to right here, because that way they are parallel to each other. You see? So that's why it's called parallelogram law. And then by that, you are able to find out what the missing angles is. Okay. And then for law of cosine problems, you only use that when two psi is known. Okay. When two psi is known. So if I have a triangle right here, okay, this A, this is my B, this is my C, this is my small a, this is my small b, this is my small c, which is their internal angles. Okay, so in order to use this law of cosine, you need to know what A is, what B is, and the angle between A and B, which is the little c. Okay, so that you were able to find out what this third missing part is. Or if you A is what C is, and you know the angle small b between A and C, then you are able to find out what the side B is, right? Okay. And for law of sine, in order to use that, you will have to know either you know two side and an angle, or you know two angle and a side. Okay, so that's when you guys know when to apply law of cosine and when to apply law of sine. And then for the 3D vector, like I said, you need to know how to do 3D vector in order to do the 3D moment problems. So for 3D vectors, you will encounter different types of 3D vectors. Okay, so first one is the coordinate direction angle, okay, which means that okay. So which means that if you see this plane right here, this is a 3D vector plane. I shouldn't draw the second that one. And this F is the F in vector form, which means that if you answer for the coordinate direction angle formula to find out what F vector is, will be in Cartesian vector form, which you will have which you will have all your I, J, and K component. And this F right here, which will be given to you guys. Let's say this F is 30, okay? And then you find out what alpha is. Well, alpha is measured from the positive x-axis. Clockwise, it's measured counterclockwise. My bad. Yeah, it's measured counterclockwise from the positive x-axis, which is measured from positive x to this point right here, because it's counterclockwise from the positive x-axis to where the force is acting. Okay, so this will be my alpha right here. And then for the beta, it's measured for the from the positive y-axis to where the force is acting, which is right here. This one is my beta. And then for my z is measured from my positive z-axis, which is right here. Which will be my gamma right here, okay? All right, and then if you don't know all of your coordinate direction angles, then which means that if you see right here, if you don't know what the gamma is, know what alpha and what beta is, then you know that when those three angles, when the cosine of those three angles square added together will be equal to 1, then you can simply rearrange the equation to solve for the unknown angle, which is the gamma right here. Let's say if you don't know what gamma is. Okay, and then finding the coordinate direction angles. Okay, so after you find out what this f right here, which this f is fr, f resultant, then you were able to find out what alpha is, and what beta is, and what gamma is. Okay, and then next kind of problem that you will see would be position vector problems. Okay, for the position vector problem, you do that when there is no angle given to you in the problem, but instead they give you coordinates, right? 0, 0, 0, 1, 3, 7, like that. Like it gives you the position of where this force is at. Okay, and that's it. Now let's call this A, point A. Let's call this point B, and then if you want to find the position between these two or distance between these two, simply just do. If I want to say, I want to find out what the position is from point A to B. So this is from point A to point B. So it'd be RAB is equal to RB minus RA. So it's from, you're subtracting from where the force is going to where the force is from, okay? And then this is very crucial to know in order to find out what the unit vector is, okay? So for the unit vector, it's simply just unit vector is equal to RAB, I mean the position vector, divided by the magnitude of that position vector. And after you find out the unit vector, you were able to find out what the force vector is. Which the force vector is simply just the magnitude. I mean, just the magnitude of the force multiplied by the unit vector. Okay. And you only do that when no angle is given. Okay. When the angle is given, then simply just do the coordinate direction angle. Okay. All right. And then to find out the smallest angle between two vectors, in which you will apply this formula right here, as I mentioned in the previous slide. This is the dot product equation. Okay. Okay. Next thing is the equilibriums, which is that's the stuff from chapter 3. Okay. For those kind of equilibrium problems, first thing you have to do when you look at those problems is that draw the free body diagram. Okay, this is very important. He will take you points off even if you get the right answer and do all your steps, but you forgot to draw the free body diagram. Let's say if a problem is worth like 10 points and you get the problem wrong, but you draw the free body diagram, he will at least give you guys like 3 points. Okay, and free body diagram, that's extremely easy. So after you draw the free body diagram, make sure to show and label all your forces, and label all known magnitude and directions, and label all the, so that you can apply summation of the force and summation of the force in the x and summation of force in the y direction to solve the problem. Okay, and I don't think he will give you guys a 3D equilibrium problem to work on, but if he did, then you have to know how to do summation of the force in the z. Okay, and then a type of equilibrium problem he gave you the spring. Okay, if you give you a spring, then you have to know that the force of this spring is equal to the spring constant multiplied by the S, in which this S right here is the spring spin stretch, which would be the final length of the spring spin stretch minus the initial length. Okay, and then for pulleys, you know that in this class, in this class up to right now, we always assume frictionless pulley, which means that if you have a pulley right, let's call this T1 and T2. Since we assume that they are frictionless, which means that this T1 will be equals to this T2, okay? And for the 2D equilibrium problem, yeah, you have to apply the summation of force in the y direction, in the x direction, and summation of force in the x direction, because you know that all of the force added together will be equal to 0, because this is a static class, it's not a dynamic class. We want the stuff to be we want the object to stay stationary. Okay. And then moments in 3D, like I covered in the previous 2 slides, if you have let's say if you have a beam right here, okay, and you have a force that's called 50 kilonewtons, okay, and this is okay, and then you want to find out what the force, what the moment at B is. Like when you apply this 50 kilonewtons to this beam right here, it will cause some moment. It will cause some bending moment to this beam. Okay. And the question want to find out that if you apply this 50 kilonewton force at A, how much moment, like how much bending moment the B experience when you apply this 50 kilonewtons, okay? And then the distance given, let's say the distance given is 8 meters, okay? And then to find out what moment at B is, simply we know that it will be the force multiplied by the perpendicular distance, okay? Perpendicular distance, not the parallel distance, okay? So it will be 50 multiplied by A, okay? And let's see if the 50 is acting clockwise or counterclockwise to B, okay? So first I assume that moment going counterclockwise will be positive and the moment going clockwise will be negative, okay? Let's see if the path of 50 to B is a clockwise direction or a counterclockwise direction, okay? So what I have to do right here is the 50 kilonewtons is acting upward, right? It's acting upward. And then so that let's follow its path to B. So in order from this point A to point B for this 50 newtons, it'll go like this, right? What kind of direction is this? This is a clockwise direction, right? If this is clockwise, and in the beginning, we already assumed that moment at B will be equal, moment at B counterclockwise positive, but right now the 50 newton going to B is clockwise, which means that I need to have a negative sign in front of it. This will be a negative moment. Okay, but let's say this 50 kilonewtons is acting downward. Okay, what I have to do is that I have to follow its path to B, which is this way. Okay, so that will be a positive, positive 50 multiplied by 8. Okay. What else am I trying to say? Oh yeah, and you see that 50 is acting like that, and then the perpendicular is 8 meters. Okay, like I mentioned, how is so that this 50 kilonewton force acting, you have to multiply it by its perpendicular distance. Okay, but let's say if I have this distance right here, which is let's say 4 meters. Okay, I cannot do that 50 multiplied by 4 because 50 kilonewton 4 meters, they're parallel to each other. Okay, you cannot do that. 2D moment is very simple if you understand what the graph, if you, like 2D moment is very easy. It's very, very easy if you know how to read the picture that the problem is giving. Okay, moments in 3D, as we mentioned, using the cross product for moment about a point. okay? And this kind of analysis is called vector analysis. You can also do it in the scalar way, but I'm not going to teach you guys how to do that because I think it's very useless and you're never going to see that again after this chapter, but you are going to use cross product over and over again in your future mechanics class. Okay, so moment mobility will be, like I said, the R multiplied by the F. Okay. Let's say this is RAB multiplied by the force A. Okay, so I will write this out: RABX, RABY, RABZ multiply, and then the bottom row will be FAX, FAY, FAZ. Okay, and then do the cross product that I show you guys how to do in the previous slide. Okay, guys, and that's all for the concepts. And in the next video, you will see me working on the problems.